So, good morning, everybody. Good afternoon and good evening, depending on where you are listening to this webinar from the IFCC, Committee on Clinical Application of Cardiac Biomarkers. And today we are going to discuss research and development is good for you and try to provide a guide how to become a researcher. And there's going to be 3 talks, one by myself and 2 by 2 very esteemed and experienced researchers, Fred Apple and Paul Collinson. So I think I will just start and share my screen so you can see my so then I think we just start. So this webinar, as I said, is called Research and Development is Good for You. And my talk is going to be doing research in the laboratory, and I'm going to give you a short introduction, 15 minutes maybe. I have some disclosures. I'm the chair of the IFC Committee on Clinical Application of Cardiac Biomarkers and an associate editor of Clinical Biochemistry. I have also participated in several advisory boards and committee and doing consultories and received grant supports and honorarias from different companies. And this is also maybe a kind of a disclosure. This is going to be a completely non-scientific and quite personal talk. Nearly everything that I will present will be based on my experience, what works for my personality, and what works in my scientific environment. So this is not going to be kind of correct answers to anything, but it's going to be more like thoughts that you can try to implement in your own environment. So as I said, a short introduction, then I will say a little bit about the female perspectives of doing research. I will give my 5 top advices how you can establish your own research and sum it up in the end. First, we are very privileged in the laboratory because we can do all kind of research. We can choose basic science. We can do science related to the laboratory profession, directed towards improving the quality through the pre-analytical, the analytical, or the post-analytical phase. But we can also even choose to do clinical research. So that's up to you. Actually, what gives you energy and what you find most interesting. There is also, of course, the large question, why should we do research? And the simple answer to that is just, it's needed. And it's needed to improve patient outcomes. And just to demonstrate this, I would like to show this figure. This shows the death rate in the United Kingdom due to heart and circulatory diseases from 1969 to 2017. This is from the United Kingdom, but these curves look exactly the same all around the globe. So as you can see, it has been a steep decrease through these years. And this did not happen by coincidence. This has happened based on the large amount on research which has been done in this period, and which is not the only reason why death rates has come down, but it's a very important reason, because without the research we would not know what advices to give the patients, and we would not know how to treat them or to diagnose the conditions. So research is needed to improve patient outcomes. It's also needed to improve cost utilization. And this picture is from emergency department, where the ambulances are ramping up and they are not able to deliver the patients because the emergency department is completely crowded. And this situation cannot be solved without research. We need to find out how to diagnose patients faster and how to differentiate between those who can go home more or less immediately, or maybe even before they reach the hospital, and those who need to be admitted. So also here, research is needed. Another reason is that we actually have the opportunities to do it. We are ourselves, and we work with highly competent staff. Most laboratories have really competent staff. We also typically have access to state-of-the-art technology in our labs, which we can use. And this is not, of course, depending on the organization you are working in. But my experience that it can be easier for us who are in the lab and who don't see patients, it can be easier for us to allocate time to research compared to clinicians, because they are all the time bound up with patient work, which is of course very important, but it could limit your ability to do research. Also, of course, if you're going to spend 40 years doing research, you need to get something back. And there is a lot in it for you if you decide to do research. First, it increases your knowledge and competence. It helps you to keep updated, engaged, and also passionate about your job. It's much, at least my experience is that people often find it more interesting to work with those work tasks which they are also doing research within. So it helps you to keep passionate about your job, and you're going to spend a third of your life in office. So it's good to do something that you like. It also gives you the possibility to improve things in your institution, in your country, and sometimes even international. And that's very rewarding when you see that you can actually contribute to change things so that the things works better. And it gives, if you work with clinical research, that will always be transdisciplinary. So you will work with many clinical colleagues, and that can be very rewarding, and you'll learn a lot about the utility of your assays and how they're actually used in patient care. And finally, of course, it helps you to make new friends. This is a picture from the American Heart Association Congress in November, where some of us met for dinner. So it's also quite rewarding from a personal perspective. I feel that I want to say something about being female and researcher, because it's not very different, I think, from being a male researcher, but it's maybe sometimes a little bit different. And this is one of the very few, or maybe the only, scientific article I'm going to show today. And that's from the New England Journal of Medicine, quite recent publication, where they have actually looked at female and males who graduated from med school in United States for 2 periods. And the short story is that your hazard ratio for becoming a professor or associate professor is much lower if you are a woman compared to a man. Here you have the reference is men, and then for women it's 0.26, so a much lower risk of becoming a professor. if you are graduating from 98 to 2013. If you're a little bit older and have had a little bit more time, graduating from 79 to 97, the risk is a little bit higher, 0.47 compared to men, but still much lower. So there is a difference. Of course, this can be due to many, many reasons. And I thought then I want to check on the Norwegian data, knowing that we are a nation where they have been working systematically with gender equality since 50 years. We have the best, I think it's the best or one of the best maternity leaves in the world. It's 1 year. We have 100% kindergarten from the child is 1 year. And we also have quite equal share between men and women in taking care of the family and everything you need to do in a family. So, but and things are a little bit different in Norway. If you look at the medicine and healthcare science, since 2020, 50% of the professors actually were women. But if you look on the total percentage, is approximately 1/3 or a little bit more than 1/3. So it's not very different actually compared to United States. And these lines down here, that's technology, natural science, and so on, and there it's very low. So this might reflect actually that there is a lot of there are more women going into medicine than men in Norway. Could in part reflect that, I think. So why is this? Well, I don't have an answer to that, and you can read this publication from New England Journal of Medicine. They have a lot of suggestions. I think it could be many, many different reasons. Our own expectations. Some question if females are less ambitious. I don't think so. Some say that we are less passionate, or I would others say less nerdy than men are. And some say that women are less brave, more afraid of failure. And I don't know. I have not no answer to this. But there are differences between men and women what we prefer to do, and of course that will be part of an explanation. Could be also, of course, society, family, friends. There is a lot of expectations on women, which are different than men. The expectations that are put on men, and that will of course contribute to this. We have this again discussion about work-life balance. It will never be completely the same for men and women, I think. And there is also some who suggest that there is this unconscious gender discrimination, that women's ideas are less noticed compared to men. I don't know if that, I don't think that's at least not men's fault if that happens. I think that is something that both sexes actually do if it happens. Also, I don't have a very good answer to what to do with this, but of course we need to do all we can to remove the societal and cultural barriers for women to come through as scientists, and we should try to secure equal rights as far as possible. And we should also be aware of unconscious bias so that we do not apply it ourselves. And finally, we need to acknowledge that humans are different and they want to do different things. Probably are the difference within a group, like the difference within females are larger than the difference between the two sexes. So humans are different and they choose different things to make a good life. I will say a few words about how to establish your own research. First of all, this was maybe not so expected, but I think actually it's quite important to do physical exercise regularly. This is a picture of #1 chess player in the world, Magnus Carlsen. He is from Norway, and he says that to be able to play chess on this level, I need to be in good physical shape. And I think there is this important link between uh, uh, physical condition and the cognitive function. So it helps you to stay sharp, and it gives you also energy, which you will need to perform research. So do physical exercise regularly. Number 4 is be flexible, because I like this cartoon very much. This is the plan you have when you start your PhD and you think it's going to be very straightforward. And this is reality, which you discover afterwards. There is a lot of bumps in the road. There is a lot of unexpected things that happen. And this is an example of a PhD degree, but it's not very different when you work as an independent researcher as well. There is a lot of unexpected things that happen that you need to adjust to. Of course, you need to stick to your goal, but understand that you sometimes have to change the plans how to get there. Number 3. Well, this is a picture from one of the highest peaks in Norway, and you can only get there by climbing. I don't know if you can see it, but this is my sister up here in the middle climbing. And there is no shortcut to anywhere worth going. So first of all, you need to design your projects according to state-of-the-art methodology. Be brave. Don't say we cannot do this and we cannot do that, and we have to do a little bit adjustment here to make it feasible for us to do. Use state-of-the-art methodology, even though it's more labor intensive and it's going to be more complicated for you to do, because you need that to get the best results. If you don't use the best methodology, study design, the result might not be valid, and then they are often not very useful. So go that extra way so that you have the best data. Also, report and interpret your data with high integrity. Remember that it's more important to present the truth than to present a significant p-value, always. And sometimes, if you want to establish your own research, it's going to feel very scary and overwhelming. So then walk one step at a time, and remember that it's going to take you a long time. Number 2, learn by your own mistakes. You cannot change the world, but you can change yourself, and you can change the way you meet the challenges in the world. And this is just the feedbacks I have got from applying for external grants. First time was in 2014, and this is not a feedback you are very happy about. They write, it's unclear what the actual endpoints are. This project is not worthy of support. And here we tried again, 2015. It's unlikely that marginal biomarkers in the acute phase, hello, we are talking about troponins here, will have any great predictive value, not approved for funding. At least it was due to high competition, but still, you're not happy about this, right? And what is wrong here? Well, the project it's a good project, but we were not able to explain what we actually wanted to do. So in 2016, it's a little bit better. At least we are worthy of support, but we did not have any money. And then finally, in 2017, and the project is more or less the same, very little change, but we have been able to explain what we actually are doing and want to do. And then we received funding. And since then, we have been Not 100% successful, but very much more successful. And what has happened here? Well, I have learned how to write grant proposals. That's what has happened. So you need to learn by your own mistakes. It doesn't help you to say that everybody else are idiots. You have to change what you do yourself. Last advice, never walk alone. This is a picture of some of the people I work with in Bergen. And you need a large team around you or a small team around you, but you need somebody to work with. Build your team and be a good team leader. And that's about generosity, fairness, and when you do mistakes, listen and learn. And also engage in and facilitate other research team. Conclusion, doing research is labor intensive and very meaningful. I highly recommend it. It's all about learning, ask for help others, and be reliable, trustworthy, and share the merit. And good luck to everybody. So then we take all the questions afterwards. And I will now pass on to the next speaker of this webinar, who is Professor Fred Apple. And he's going to talk about the who, why, what, and where of research and development, a view, thoughts and importance of research in clinical chemistry.
Can you hear me okay?
Yes, we can hear you, Fred.
Right.
Welcome.
Thank you, Kristen. And I just did learn from your talk that humans are different, which is, I like that. So thank you very much for IFCC for sponsoring this and our opportunity to the three of us to present today. I'm going to give you, again, it's a personal, experienced point of view, which I learned tremendous amount from my mentors and my division chiefs and my chairman, people who do research. Somewhat, it could be hospital-based or academic-based, or even not so much industry-based, but just my own experience. The first time I've really given this talk, and here are some of my disclosures, which I won't go through. But I'll start with this. And my dad said to me once, "You're never going to find a job looking like this." My dad was an accountant. So when we talk about humans are different, my question to you, would you trust this scientist based on what I'm going to tell you today? This is what I dug out of my archives my first week on the job in 1982 when I started my job at Hennepin County Medical Center at the University of Minnesota. So my concept and approach to research, whether it was back then, today, or tomorrow, still concepts what I learned as a grammar school student, the who, what, when, where, and whys. And one of the important things I think necessary is when you take a job or you're interviewing for a job, is you need to have a discussion with your potential boss or your boss and understand, does the job allow you? Does it support you to do research? Not so much financially, but just the time wise, or can you make time to do research? And you have to work out the agreement plan with your supervisor and understand how it may affect your job performance and for promotion and what the role is. Because if your institution doesn't have a mission for research, it may be difficult to do research, and you may have to consider, is this the place I want to work? Now, I did some archival work for this talk, and I went back and pulled out my Ph.D. thesis and one of my latest papers. And when I look back, I wanted to be a college professor, and my thesis was called Manipulation of the Fatty Acid Content of Mammalian Plasma Membranes in Tissue Culture, 1979. And where does that go from to a recent paper that I published, as Kristen talked about, which I will, about the collaborative efforts we established, is a high sensitivity point of care whole blood cardiac troponin I measurement to rule out myocardial infarction and risk. So how does one get from there to here? And clearly, as I support what Kristen had mentioned, it is a challenge. But it's up to you if you're going to pursue this. You have to make it a fun and enjoyable one, because if you don't enjoy your work, I think you need, no matter what field you're in, you need to reconsider. So I dug out this painting. It's a Norwegian painting, and it just helps me. I'd ask the audience if I was present. It helps me remind me is it's a scary road or a scary river that we take to try to get to what we think we're trying to do to get to our endpoint, especially in research. So my top things will be like Kristen had at the end. I'm going to intertwine them in here. So I think you need to start, you have to have an idea. You have to have a research idea that can be started, and it has to be realistically completed in a period of time. And I always view it as a movie I saw once, a Disney movie, and you have to start with a spec. It might be one analyte, it might be one focus, but you're going to have to ask questions on that topic. And along the way, there's going to be more questions that could lead to different projects, but this is going to involve, so that one spec you study could be, for me, my spec when I first started in my fellowship, I was studying ion selective electrodes and calcium and sodium and potassium. There's nothing wrong with being a generalist in the field. It's up to you to decide and study isolated questions. But what I've learned is the strength of your overall work, starting with that spec, and if you were successful to build on your program, uh, it really does have, as Kristen said, a huge clinical impact laboratory medicine has in clinical practice. And we are a solid component of the clinical world now because of our research. So one of the ways to how people understand our research is the importance of publishing your data in peer-reviewed journals. It's really what strengthens your ability to, one, and I'm going to talk more in depth about this, fund projects, get sponsors. Because when you have sponsors, whether it's in the US, the NIH, or it's an industry-based study for a self-initiated study, everyone seems to want recognition, which is a positive thing, because the only way we can get our science out there to see what other people are doing is publication. It also helps you get invitation to give talks, to talk about your research in your group. And what does that do? It helps you collaborate, and it helps, like here today, three of us are either members or consultants to the Clinical Applications of Cardiac Biomarkers IFCC committee, a great way to advance your science. So I'm going to talk about my spec for 2 minutes before I move on. My first rotation as a clinical chemistry fellow at Washington University in St. Louis, we measured the CKMB by agarose electrophoresis. And in one of the runs that I had, actually, this is a run that I ran as part of a clinical research project, is the CKBB fragment showed up after we developed it as a heart. And it turns out that this sample on there was some skeletal muscle. I'm going, what is the heart doing in skeletal muscle? Because we all learned that CKMB was from the heart. And this led to a project I did with another colleague happened to be a biostatistician colleague, my friend Matt McGew. We ended up, again, don't be afraid. We actually wrote up our findings, which comprised a series of blood studies over 8 weeks, training for a marathon. And we said, what the hell, let's submit it to the New England Journal of Medicine as a letter, and it got published. Crazy. And that led to, again, other questions. Where is that coming from? And we did muscle biopsies working with a physiology group to look at abnormal skeletal muscle after running and training for a marathon. You can clearly see the differences in the striation. Now, my spec was always based around muscle. So where over the years, I'll show 2 more science slides, is it grew, that spec from agarose electrophoresis grew to collaborating with an individual, Jack Ladenson, who had a monoclonal antibody developed in his lab for CKMB. And this was the first paper we published in 1999, the first troponin assay to show how the ROC curve here, how important and improved that small research we started looking at MB, not specific for the heart, grow it a little in discussion with collaborators. And now we're showing that troponin is really the more powerful tool for the diagnosis of myocardial infarction. Where has that led? I'll show at the end my collaborative, but it led to a whole program in the lab. And there's no room really to be a Renaissance person anymore. You really can't do when you're looking at diagnosis and risk and assessment. You really have to develop a project, and this does take money and it does take a lot of effort. So let's talk about what I'll call the balancing act. We're often hired uh, looking at what are your roles? Clinical service, probably predominantly why you're often hired as a clinical chemist, at least in the US, unless you're a straight academic. There's administrative responsibilities, there's regulatory issues. You have to watch the lab all the time. There's teaching roles, whether you're teaching medical students or residents or fellows. And then there's research. Excuse me. And I think it really stands you out if you are laboratory medicine and also doing research, because it really distinguishes you from a lot of the other colleagues. Now, it's a career choice you make, but it's one of the things I have really enjoyed, because what it does then, it draws your clinical colleagues to you to work with you. So I think it's a pursuit that you have to like, and they have to figure out how you can do it and how you can fit them into your work week, which is really clear here. That's not a 40-hour work week. Research is, these are some things I've learned from mentors and chairmen. I hate these words, but some of them are true. It's surviving, it's thriving, it's the willingness and interest to put the time in, which really what it takes. So, excuse me, I got a crick in my throat. So I use this word, someone used this word once called hands. How do you get the work done? You saw what I looked like when I started, was doing some of my own work, but you can't have the job unless you have employees that you work with, staffing that you can collaborate with, whether it's students, undergraduate, whether it's medical students, technologists, research coordinators, postdocs, MDs, or PhDs, or medical residents. There's going to be a subset within your residency program in medical school or even in the hospital where people are going to be interested. So you have to reach out to someone who could send the word out. And surprisingly, people are going to call you. Then there's money. How do you pay these people? How do you come up with funding? Today's world, there's not a lot of money out there to research. So you have to be creative. You have to hopefully maybe you get a little startup money or if you're going to start a job, but that often isn't the case if you're hospital based. And then you have to figure out how to write grants and contracts. And it's a skill that Kristen pointed out, that sometimes you don't always succeed the first time, but you learn. And a lot of it is when you meet people. And then there's the science. I talked about the spec and how it grows. You have to build your resources. And the important thing is you need to get your data out. All right. Staffing, I mentioned that is how you build this laboratory. What are the disadvantages? You're relatively new. You're relatively unknown. You're this newbie with in my case, like my father said, you look like a freak. And second, you may not have the students yet to be attracted. But the advantages of being young is that really students, especially and technologists, they're attracted to labs of young faculty. You're viewed as dynamic, you have energy, you have more hands-on, and the student sees that in this new PI, and they enjoy working with you because you're more available to talk about things. Also, when you teach, never give up the opportunity if you have a research lab and you're meeting with a group of people, maybe to throw a slide in at the end to say, here's my research. There's going to be someone also interested in that. You can't imagine how someone's going to come to your doorstep and ask you, hey, can I work with you? And they're not looking for salaries. They're just looking to get a foot in the ground because they might have an interest in moving in the same academic career or research career that you are. And then the other thing that's important is to go over papers with them, journal club, discuss it, discuss the methods. And to us in laboratory method in medicine, methods to us is the most critical thing. And many times we see journals published when you read let's say a biomarker-based study, there's nothing in the methodologies that say how they got those results. So we need to help educate as part of research our clinical colleagues to make sure things are published. Staffing. Uh, we work in a hospital. There are potential for technicians, technologists. If you're university based, there are a lot of hospitals. Again, finding students. Most students, as I said, want to work maybe several years before they go to graduate school, They want maybe they want recommendations. They want experience. So people will come. Clearly, you have to find some ways to pay these people because everyone has to put food on your table. One thing I've learned, and this is very important when you talk to HR, there's been many times over the years you hire someone that's not working out. They are not interested. So it's really important. Sometimes it's not easy to, I hate to say, cut them loose, but this is a quote I took from another scientist. So you have to figure out mutually how this works if you hire someone and they're not really moving towards the direction you had hoped. And lastly, what we've learned in the lab medicine world, everything is regulatory. If we're doing applied science and working with industry, everything is based on regulatory in our country, in the US, FDA regulatory. So it's your research. Research is important as you keeping the regulations under the proper standards. In the drug testing world, and I have a hat as a toxicologist, in the sports world, the race isn't over and the drug test is negative. Same concept. Your data, if it's not following regulatory procedures, it's not going to fly. So next, I think one of the most important things getting the science done is you hopefully either find a mentor or your institution might have a mentorship program because it really helps to have someone to talk to. It might help that maybe you're going into an institution where to get a laboratory space, you have to pay rent. So often administration is not going to hand you a 400 square foot, 300 square foot laboratory and not expect rent back or overhead. So sometimes you have to start out in other individuals' laboratories and maybe they have space for you. Hopefully they do, and maybe they have a room. And then you build up your resources and you see, because a lot of places will have core facilities and core instruments. So you try to quickly learn how to do that. Actually, as important as when you do get new data, it's very important to write it up quickly. I mean, I ask everyone, I ask for a show of hands, how many people find their data and it sits for a week, a month, 3 months, and you haven't written it up? So I like to write. I encourage people to write up their data quickly, have someone proof it, send it off to a paper. It doesn't have to be the New England Journal of Medicine. You pick a journal that, I don't rank them A, B, and C, but pick a journal that's reasonable as you as a young clinical pathologist, clinical chemist, you get a good review. And as Kristen said, sometimes you get reviews that aren't favorable, but you learn how to improve your writing and your data presentation, and it will get accepted. Where does that lead you? It leads you to going to potential local, national, international meetings where you meet people. And the more people you meet that have similar interests, the more you stay in touch. One also thing is even within your own institution, even if they're not doing research, let's say I'm in the world of cardiology and lab medicine, talk to your cardiologist, talk to your emergency medicine physicians. They'll come up with ideas, even if though they're not doing research, what they will need to improve their patient care. So let me just show you some pictures where I've been very fortunate to show you my progression. So in my career, I started with that spec and I met people like Art Carman, who was the first to devise a AST for cardiac troponin, for AST for cardiac biomarker for heart attacks. Guys like Bert Sobel, cardiologist, who's CKMB, Jack Ladenson, troponin. But the king of them all was meeting Sidney Rosalke. He was really back when it was total creatine kinase. He was in the United Kingdom, England, and he showed me. He was out to dinner with industry, and he was in Paris, wrote down on the menu exactly what he wanted to do when he developed the reaction for creatine kinase to measure in clinical laboratories. And the last individual in the cardiac world, Hugo Cottis, who really was the one who developed cardiac troponin T. Where does that lead you? It leads you to other colleagues. And, Kristen, your talk, it's kind of scary looking back at this early IFCC committee and the first European Society American College of Cardiology committee. And there are no women on these committees. And that's kind of a sad statement for the time. But you meet people from not only your own country, from internationally that helps you get ideas and helps you foster your ideas. And where are we today? Well, let's take Kristen's the chair of our IFCC Committee on Clinical Applications of Cardiac Markers. And I think we have a pretty darn good mix of sex and nationalities around the globe. And no, we can't meet in person, but we do meet by Zoom every month. And our current fearless leader, Kristen, is the one helping us move forward in the science that we develop. So funding. How do you get funding? I think one of the ways that will be helpful is, I talked about this, is you find co-investigators who maybe they're more senior and they're mentors that help you figure out where are the best places to go. Industry is a wonderful place to collaborate with, and you might meet somebody who comes into your hospital lab because you just brought up a new instrument in your lab. It could be Siemens, Abbott, Roche, Ortho, Quida, whoever. And they'd say, we're interested in studying a new marker we're bringing up on this assay. Could you help us do the validation? So it could start from a one analyte instrument evaluation that leads to a pre-market clinical study. It could start just at a single site like your own, or next thing you know, you find out someone in Christchurch, New Zealand is doing the same study, and you collaborate. And then as you get more confident, you have more data, and your lab maybe now has 2 or 3 people in it, you think about approaching, this is truly with industry, an investigator-initiated studies. Most industries have now formal applications, just like national grants in the US. We have NIH, or private foundations like American Heart Association. All these organizations have granting agencies, which are very, very competitive. But if you're not afraid of rejection, you need to apply. Collaborations, joint publications are a great place to start. If you're an academic center, they put a lot of weight on if you're the first author. That means typically you wrote the paper. If you're a senior author, maybe it was your research design and you work with the first author. If you have graduate students who are doing Ph.D. or master's thesis, is a good way to get research off the ground. And I've heard this many times, and it's can't be downgraded. Depending on the tracking you're in, sometimes you have a clinical education, but if you're in an academic track, promotions are often going to be predicated on how you publish and where you publish. So collaboration will definitely accelerate and potentially improve your thought process and your research into areas and help you think, giving you the scientific diversity that you need to get funding. So I finished with a couple slides here. My dear friend Mario Plabani from Padua, Italy. I was fortunate enough to, from my growth in my research, to be invited to speak in Padua. And I think it was Galileo Auditorium I spoke in. And for some crazy reason, he thought all the planets rotated around the sun. But in my world, scary for the last 40 years, have rotated around CKMB and cardiac troponin. So I leave you finally is from that bearded guy I showed you in the beginning to, this is a couple of years old picture of my research group in my own lab, where Karen Schultz, second from the left in the front row, is my research partner director. But you can see how my lab fortunately has grown internally. We now have 7 full-time people in my research lab, and we've collaborated around the world with some really wonderful colleagues. And I apologize, this is an old slide, Kristen and Paul, but my colleagues Paul and Kristen belong on this. I need to get them on here. Thank you very much for listening, and I look forward to answering any questions.
Thank you, Paul, for this wonderful talk. Sorry, thank you, Fred, for this wonderful talk. I really, there is a lot of things you need to think up and reflect related to this, and we will do that afterwards. But now we will move directly to Professor Paul Collinson from United Kingdom, who is going to take us further in this webinar. So welcome, Paul.
Thank you, Kristen. Good. You can see me. Can you see my slides?
Yes, we can.
Excellent. Right. Well, in this talk, because we're talking about starting R&D, I thought I'd actually consult with someone who is just starting doing R&D. So I've developed this talk in collaboration with my daughter Stella, who is a trainee obstetrician in Manchester, and she and I put this together. So here we go. So R&D is good for you. So three things really. Why do R&D? What do you need to do R&D, and then how to do it? So let's begin. Well, why do it? I put this under the heading of know the enemy, because if you have direct experience of writing up clinical studies or performing research, then you're going to know when you, or have a much better insight when you read somebody else's publication as to what is real and what is actually questionable. And it's true of just about everything in this life that if it's too good to be true, then it is. And the posh word for this is, of course, critical thinking. So why do R&D? It's good for your brain. It's very satisfying to solve puzzles, and life starts to become much more interesting. And it's good for your social life. You get to network with colleagues, and I've had some very memorable evenings out with Kristen and Fred and Alan Jaffe, etc., etc. And many excellent research projects begin with a glass of wine or beer or dinner. And in fact, I recommend dinner, but you can often discuss and develop quite interesting research projects over dinner. I find a modicum of a decent red wine lubricates the brain cells magnificently. Other reasons why we should do R&D? Well, yes, it will benefit patients. And this is what Kristen said earlier, and I think this is absolutely right. You'll identify solvable problems. It's important to the individual. And that's your mother, your father, your partner, or your child. And for your own part, you'll learn to be a better diagnostician. It will also help to educate your colleagues. It's going to be good for your career. And most importantly, you will learn patience and perseverance. This is what we refer to in the UK as character building. And it's fun. But it's also very frustrating and annoying. Kristen nicely showed what happens when you put the same research grant in, and the first time you get their response back says, "This is rubbish." And you think, no, you don't understand, you're idiots. But it's just because you haven't expressed it properly. So what do you need to do R&D? Well, first of all, you actually need an inquiring mind. You've got to look out there on what's happening around you and say, I wonder if this is right. And just because someone says it happens in a certain way doesn't necessarily mean it always does. You certainly need to enjoy the idea of being a detective. So whether you're talking about Montalbano, Poirot, or Sherlock Holmes, hunting for the diagnostic clue that your colleagues have missed, and of course, in the case of Montalbano, usually enjoying a nice meal at the same time. So that must be good. You also need an interest in your discipline and an appreciation that as a worker in a diagnostics lab, you have a whole hospital of potentially interesting cases, and these can vary. Also, a very useful thing is to have a friendly statistician or helpful statistical software. And in fact, one of my first papers, which I published when I was a very junior doctor, I did because I basically did all the statistics for my co-investigator, who was an orthopedic surgeon, and we know that they can't do maths. You need to be inquisitive. So seek out curious test results. And if a clinician comes and asks you about something, regard it the same way a squirrel would as the last peanut on earth. Pounce on it. Be helpful. Go and talk to people. Support people's projects. Because if you do this, it will mean you acquire a reputation of being helpful and worth talking to. And they will then start to involve you in their projects. They'll come along to you and say, oh, could you help us out with this? And then you can boldly go where no researcher has gone before. Be accessible. Be the go-to person in the lab. In my own lab, I've always had people turning up asking, could you help us with this? And never say no to people. But you may sometimes have to, as they would say, manage their expectations. Because if they want to do a test that requires you to procure a cyclotron for your laboratory, this may not really fly. Be interested when people ask about something and always offer assistance. How to do it? Start small. Case reports, audits, data collection. These just start getting you in the swing of things. Cultivate contacts, clinical colleagues, other researchers, industry. Fred mentioned doing a collaboration with industry, and this is actually really good because they quite often people will turn up wanting to have a new bit of kit evaluated and just say, oh yes, we'd be happy to do that. Mentorship, very important. I was very fortunate in my own career to be actually mentored by Sydney Wazalki, who Fred just mentioned earlier. Do projects, but when you do a project, under promise and over deliver. This is really important. Be keen and available. And as Fred said, you're not going to do it on 40 hours a week. You must be prepared to work out of hours and at weekends. Present things. Start by presenting at local meetings. This isn't too bad. You just you just are afraid that you're going to embarrass yourself in front of your buddies. Then you start presenting at larger regional meetings, and this is when you really start getting worried, and you think, oh dear. Then start presenting at national meetings. There you're really fearful. And finally, you get to your first international presentation, where you will be truly terrified. I remember I was on the first one. But the more you do, the less scary it gets. Most important thing, keep it simple. Often referred to as KISS or KISS with 2 S's for keep it simple, stupid. Talk slowly and clearly. Do a presentation skills course. These are really valuable. As Fred said, it's all about the money. So you need funds to start on your research career. Most importantly, cultivate your local research office. Look around at local R&D and charitable funds. These are often aimed early stage researchers. National charities, and not just the obvious ones. If you want to research something, there will be a charity that will give you money. It might not be a lot, but it'll be some. And don't assume that you're just going to get a massive 10 million grant first time round. Look for multiple pots of money that you can put in to your project. Look for academic development funds, look for training funds, and then go to national R&D bodies and research councils. And these will quite often have early stage researcher funds. Once you've got going, how do you continue? Well, it is a truth universally acknowledged that someone with a research income at $5,000 a year is in need of a grant, with apologies to Jane Austen. So a track record in research makes the next stage much easier, because as they said in The Lord of the ring needs gold to breed gold. And once you've got one research grant, it's much easier to get the second one because you have a track record and you have proven that you will deliver. Become a pro applicant on grants so you learn how to do it without having to do it the painful way. Become an associate principal investigator through sponsorship schemes. Finally, be a principal investigator on small grants. And again, here, under promise and over deliver, under budget. A really, really good wheeze here. Make friends with reagent equipment suppliers to get discounts or free of charge kits. When you make grant application, put the list price on. Then you have financial flexibility. Apply as a PI, and here you have to build up a research team, as Fred and Kristen said, and join up with others to form research groups, locally, then internationally, so you can pool locally obtained funds. Also, it gives you much more credibility, both locally and internationally, if you're working with other figures who are well known in the field. And finally, look at appropriate commercial collaborations. You do not have to sell your soul to work with industry. And in fact, with all the commercial collaborations we've done, it's very much been on the basis of you put up the money, we'll do the research, and you just have to live with the findings. And after the initial sudden gulp from your commercial colleagues, they usually accept that in fact this is what they need to see. What industry needs is independent confirmation of their claims. And have plenty of patience. Only about 1 in 3 good applications get funded. And then collect your Nobel Prize for your brilliant research, and not the Nobel Prize alarm clock. Thank you very much indeed for your attention.
Thank you, Paul, for this excellent and very amusing talk. I really enjoyed listening to both talks, and I think it's yeah, I agree with you everything you say. We have some questions here from the audience, and I think I will start with one here, which says, "What kind of research study should the clinical chemistry laboratories initiate and perform themselves?" Any comments on that?
Well, I think the answer to that is anything at all. I think that you start with anything that's of interest, and then you develop an interest and an expertise. And my initial work covered a very broad range of things before I finally coned in on cardiac markers and obviously point of care testing. But I think it should be around something that you're interested in, something where you think there's a clinical need, and ideally something that nobody else has done to death. What do you say, Fred?
Yes, I'm getting my mind back to my early career in the early 1980s, and I'll give you an example. The first several months on the job, all you're doing is trying to understand the clinical lab, and we had one of the first. It was called Kodak Ectochem 400s, which turned out to be Ortho, which is now Quidel Ortho. But they first developed a 2-cartridge creatinine assay, right? Enzymatic from the old Jaffe method we used to run. And they needed help evaluating it. And we had one of the early instruments in our hospital lab. So where you start over might not be what that spec is that you're going to really develop a program in. But as Paul pointed out, they helped fund it. They gave you some reagents, small amounts. You produced the data. You actually opened the eyes that they identified an interference of ammonia, which was a problem. They actually pulled the 2-slide technology. We published it. And as Paul commented, and I totally reiterate, and Kristen would say the same thing, if you start it, you complete it, and even it's a small publication in clinical chemistry, they come back to you again. And it allows you to, let's say you get funded for $5,000 and you use 4, you often can start pooling some of your resource money into we'll call it a reserve account that could help you fund other projects that you devise. So you start small and you grow from there, but it doesn't have to be that spec where you're going to end up. You can still do that generalist type of work because industry is often a very good way to start.
Yes, I do agree. I want to add one thing. You when you start, you have to acknowledge and pay attention to what resources are available for you. Who can be your mentor? What can they teach you? What kind of studies are going in your institution where you can learn from? So it's not that you have to do either observational trials or randomized trials or developing assays, or it doesn't have to be one of these. You have to look around and see what is available in my institution. What can I actually learn here? I think that's one of the key things. And then when you have learned how to do research, you can expand on that and establish your own things, what you are most interested in.
Let me just note one thing none of us touched on, which is critical. Back in the day, a little earlier than Kristen, when Paul and I could do these quick and dirty studies in the lab and pull patient samples from the refrigerator. But in today's world, everything has to go through your IRB. Everything has to be approved. Any patient record related research, at least in the US, I think internationally, you need to get IRB approval from the local institutional review board and before you start any research. And that is critical. And that is something often you can't rush into things sometimes. It gives you more time to think about the project, but that IRB application and approval to be able to do those studies becomes very important.
Yeah, well, I mean, one comment I'm going to make about research, though, I mean, Kristen says you learn how to do it. I think I'm still learning. Every time I finish a study, I look back on it and think I could have done that better, you know. And I think you go through a continuous cycle of improvement. I'm pleased to say, though, Fred, we're not quite as bad in the UK. We are allowed to use anonymized samples still without having to. And although it's probably quite a good wheeze to go to your research board and explain you want to do, in general, method evaluation and get a blanket approval for using these before you start, then you don't have to try and have to do it each time. But I agree, the regulatory environment has become much more exacting. I remember one of the very first studies I did was on interference on Cinemet on the VMA reaction. You remember VMA for Cinemet interferes, and I got 6 of my friends to take Cinemet and collect their 24-hour urines. I don't think you get that through these days.
Kristen, one more comment may I make?
Yes, please.
One of the things, and I'm not going to, none of us touched on genetic information. That's a whole different world. So let's skip that. But one of the things that also is very popular today when you start developing and takes long-term planning is to build biorepositories.
Yes.
And so in the cardiac world, which all 3 of us are involved with, let's say you want to, some procedure related potential myocardial injury in the cardiac world. If you're doing one patient IRB approval, but if you get IRB approval to maybe collect waste specimens, you can start building up biorepository, which may take a year to get 1,000 or 1,500 patients, because not a lot, as Paul said, unless you can present data in a statistically meaningful way. An N of 20 might be a nice case study or a series of cases, but you need bigger data. So during that time of a year collecting, or 6 months to a year, it gives you, as Paul said, time to go over your thoughts, and maybe new biomarkers are out by then, which you could add to the study. So the biorepository concept is very powerful, needs separate approval from the IRB, but can be often useful for many studies that you do as a starting point.
I completely agree. And this is also something that we can offer to the clinicians, and that can give us access to their studies, because we can do something very useful for them, and like you can maybe expand the project with 1 or 2 extra PhDs if you have a biobank. We have to move on a little bit here. So there is one very good question about publishing. And here it says, how can we recognize predatory journals to avoid sending papers to them? And this is a really good question, and I think we have 3 editors now on this webinar. So and I think we should start with you, Fred. What do you suggest? How can we recognize predatory journals?
Predatory journals?
Yeah,
Well, I'm not really sure how to answer that specific, but I think within your field, you will know which journals are good journals, reputable journals with they all have citation indexes. They all have they're all kind of in the field of how good a journal is a system. They have impact factor, which tells you how many papers are published and then cited within maybe a 2-year period. That tells you the impact factor of how available and how many people are citing papers from that journal. So listen, in the cardiology world, we all would like to publish in journals like Circulation or what's the top cardiology journal in Europe? Is it Heart? Uh, so sometimes you can't start at those. And sometimes you have to choose your own field. And we have many good journals in our field of laboratory medicine and clinical chemistry. And I don't want to leave anyone out, but we have clinical chemistry, of clinical chemistry laboratory medicine, clinical biochemistry. We have, the annals of is it clinical biochemistry. There's many journals out there. These are probably respectable journals. The predatory journals, if I think I understand your question, if someone's inviting you to write a paper for a journal, you need to do some homework to understand, is it a journal that your colleagues are reading? And I would avoid those and try to stick with the mainstream journals. Again, as Paul said, ask your colleagues, where are you publishing? If someone's offering you money to publish a paper, it's tempting when you're making, 12 cents an hour. But the bottom line is you don't want to go there early in your career, right? Or ever in your career.
Yeah,
You want to add something, Paul?
Yeah, I was going to say, I think that Fred sums up. I mean, it's a bit like Groucho Marx, really. He said, I wouldn't be a member of a club that allowed me in it. If you get an email encouraging you to publish in a journal, then that I'm always very dubious about that. I actually regularly get emails suggesting I publish in journals, and I'm never sure what I'm supposed to know about nuclear physics and things like that. But I get these things, wouldn't you like to publish your paper in? No. And yes, you go for what's reputable. I mean, it may be that some of these sort of, I would say, to decry them as upstart journals may become good, but basically start with what's well known. If it's been in an existence for 20 years, it's probably reputable.
Yeah, I can just because I don't know every journal, and what I do is that I check always, is this journal on PubMed, right? So if I publish in this journal, will the article be visible on PubMed afterwards? So that's and then I check the impact factor. I check if it's because if it's a very new journal, they don't get into PubMed in the first maybe 1, 2, 3 years. It takes a few years to get into PubMed if you're a new journal. So if it's a very new journal, I check, as you said, who are my friends publishing here, and who is the editorial board, and what is the acceptance rate here? If there is a 95% acceptance rate, and there is I don't know, 3,000 euros fee to publish there, well, then probably the review process is not very rigid, right? So then it's somebody who just want my money. Yeah, I check a little bit about the journals before we go there. Yeah, there is also a very concrete question. Would you pay to publish in a journal that is not on Scopus? I would not do that. Anybody? Any other suggestions?
Personally, in my career, I haven't. Some journals require you have to pay for pages, but and yeah, like some of the journals charge you to publish, but they're very reputable. That's how they keep the journal alive. But I don't think in my career I've actually paid to get into a journal.
You sometimes have to pay an open access fee, but that is something else.
Correct.
Yes. I think we should move on a little bit. Here is a question about when you're a researcher in a low-income country, how can I create collaboration with researchers from countries where the research in biomarker is suitable to be performed? This is a difficult question. Any comments on that?
Sure. I'll give you a real example. I got an email from a person who happened to train at the same institution years ago I trained at, who's in a developing country, and the request was, hey, could we consider working together on a project? And I'm going to have a dialogue with her this next coming week to see how to give some advice, kind of in a sense, we'll call it mentorship in a sense, how we can approach for her to get reagents, which are too often expensive for her to buy for her hospital laboratory. So I think it's a slow process, but don't be fearful to email someone. The worst case scenario is that they don't respond or they say they can't help you. But if you don't reach out to try to get some assistance, you have no chance to get that. Does that make sense?
Yes, I think so. Absolutely. Paul, what do you have any comment?
I think we lost Paul. There you are. Can't hear you, Paul.
You are muted.
You're muted. Oh, his voice is not good, he said.
Okay.
Right. So I think, I think it's don't be afraid to reach out to ask, call up Kristen and, and ask her if she can't help you, maybe she can give you some advice of who to contact. Maybe sometimes it just involves contact someone in industry at a higher level versus your local level who sees benefit in what's going to happen at the hospital because it could develop regionally and across the whole country. So don't give up until you've tried at least 3 strikes, possibly.
Yeah, I think one of the things that I have had the largest success with is actually to invite people to collaboration, right? If I have a research project and I need some kind of help or validation cohort or advices or things like that, I have invited people to collaboration, and that has been I've learned a lot from that. And also, I think it's important that it's a little bit about formalities as well, because there is a lot of things you cannot do, but you can always be engaged as an advisor or somebody who can support and help.
Sorry, I lost the ability to actually unmute myself for some reason.
Can I just let me just comment real quickly, Paul, while Paul gathers his thoughts, is this collaboration concept. And I found it fascinating. Well, first time it really hit home when COVID hit, at least in my worldwide, but in my hospital as a local, is everyone was fighting for the same waste specimens to do studies: virology, immunology, lab medicine, internal medicine. And it kind of forced someone to get that whole group of 6 people from different disciplines. I know this is a little off the question internationally, but where I'm going with this, it forced 6 of us to come together because one person was collaborating with a country in West Africa. So how quickly this project moved from someone I want to work as a team, and hey, let's throw a couple other inflammatory markers in which you weren't thinking about versus the antibody and antigen testing for COVID. So it kind of grew that way. And then we brought in the West African PI into that, and it kind of grew into a bigger study.
Yeah, that's fascinating how things grow. Yeah, there's one more thing. It's also a little bit on the side, but which I have been thinking about, because when you are young and you are about to establish yourself, you need a lot of help, right? So we have all talked about mentoring, and you need a mentor, and so. And typically, when you come directly from, you are accustomed to being the pupil, and you are looking for the teacher, right? And you are used to that. You can always ask your teacher for help, and you don't need to give anything back. But then when you are establishing your own research, you need to remember that if you all the time ask for help and ask your mentor for help, you have to give, at least after a while, you need also to give something back. So you have to offer like co-authorship and cooperation, which is also fruitful for them. Because if you always then ask for help, and forget to give something back, people's gonna get tired of that. So to build this good collaboration is always about giving and taking, and that remember that there is not anybody who is so like established that you don't need to give anything back, I think.
I think I would agree with that.
Yeah. So there is another question here. Do you see artificial intelligence research in the clinical lab taking, and can this take over normal practical testing in clinical research?
Well, before I signed on to this, I had to check a box that I wasn't a robot. Okay. To be honest, personally, artificial intelligence, machine learning is kind of working its way through the cardiac biomarker world, in cardiac diagnostic and risk world. I'm not really sure I am up on it enough to understand the pros and cons and the validity and what is real and what is not real. So I really can't offer a solid statement except that it's here and it's coming and it's going to get better. So there's going to be regulations, as we all know. We already saw that internationally. So by the time this becomes a powerful tool, the artificial intelligence programs, statisticians are going to have to show it's better than what we currently are using in practice here. So I think we'll have to see how it evolves, and I'm sure it will evolve. That's kind of my view on that. Paul?
Yeah, I think it's a tool. People forget that people have been working on artificial intelligence for about 40 years. And what's happened is it's gone through various iterations. And I mean, I've been involved on it occasionally as part of other projects. And it was always going to save the world. And then it never quite did. And at the moment, there's obviously great enthusiasm. And laboratory medicine, in theory, is actually a very good field for AI because it's already a numeric discipline. So it ought to be relatively straightforward to put things in. But we all know that you can't make a clinical diagnosis solely on the basis of numbers. I mean, I always joked that if I could replace my ED doctors with scans and lab tests, that would be great, but we can't. And we all know that, for example, just for a troponin, a single elevated troponin has a multitude of explanations. And it may be that systems that incorporate AI are more efficient at teasing these explanations apart, but not yet, I think, is the simple answer. And things have to be mature. At the moment, AI is basically just a cleverer way of doing what we were doing before, but doesn't actually think yet. Humans are quite good at thinking, except politicians.
Yes, I do agree, and I don't think we have seen. We have only seen the beginning of this, right? And with this Chat GPT, there is a more advanced version of Chat GPT I've learned, and I wonder if maybe in the future we will not write reviews. It will be, we will just get the Chat GPT to write them, and then we will go through to see that it's actually correct what is stated there. So things are going to change very much, and also the way we diagnose and interpret clinical parameters and
it's quite interesting. I refereed a paper for JALM where they had got Chat GPT to write an article about CKMB, and then they'd gone over it to see how good it was, and the answer was it wasn't very.
Yeah, I'll just make one comment. Listen, Paula and I are way at the end of our career, towards the end of our careers, and well, I would recommend someone bring some index cards to make sure to look at when you don't forget anything. People now are bringing their laptop computers to make sure they don't, and they can scan things and look things up on the fly. But where I'm going with this is, from my experience as an associate editor of clinical chemistry for 30 plus years, even with the review articles you mentioned, Kristen, there's a personal touch in the writing, which, and I've read a lot of these GPT things that you miss. And it even, I'm from a family of my wife and my daughters are artists. When I see paintings that have been produced by AI, when you get close, you don't see the detail that the artist has put into that scene. So I reserve judgment to see what the impact will be. I hope it has an impact in medicine as a complementary, not as a replacement.
Yes, I agree. Okay, we have quite a few questions which is about, like in my department, we don't have a research fund, so we don't have access to research fund, and because there is maybe a research development department in institution or in my country, we don't have so many masters or doctoral programs in clinical laboratory areas, and so it's not accessible, and people ask how can they come around this. Should they change their job? Should they change how can they start to build up research communities when there is very little access to resources?
Well, I can only comment from my own personal experience. My first job as a consultant, in fact, was not in a teaching hospital. It was as a head of a service lab in what we refer to in the UK as a district general hospital, so not a research institution at all. But that doesn't preclude you from doing research. And in fact, my first pot of money came from doing drug trials, which obviously any hospital has potentially people. So we did lipid. It was in the days when lipid lowering drugs were new and very new indeed, and we actually did some of the early statin trials. And of course, that then generated money to put into a pot, which then meant I could employ somebody. Which Fred's met him, David Gaze, who's gone on to higher things now, and on the basis of that, you can then start building up your research base. But I think, Hennepin's not it's a university hospital, isn't it, Fred? But it's not primarily an academic institution, or am I incorrect?
It is a teaching affiliate of the University of Minnesota, but fortunately for us, in our mission statement includes research and education. And we have our own research institute, but it's an independent of the university. But let me just add to what Paul said. If you were done, Paul, are you done?
I'm done, yeah.
So, Kristen, I think the way I've approached that over my career is young faculty that are interested in let's say, your area, but they don't have the funds or the resources. You bring them into your own operation. You give them a desk, and and then you give them an opportunity to at least build something as part of your group, but as an independent and still principal investigator. So you maybe end up paying some rent for them, but today's world, people are data mining. You have everything's electronic. Our electronic health record in our hospitals, Epic. You have the ability to go in there and start some research and some trending stuff, as Paul had mentioned, and take a look at that and try to build a database that could show trends that might interest to get funding for research. And I think that's a strong possibility today to do. We could generate projects, and especially you get that one medical student that wants to rotate 6 weeks in your lab, and their skill sets are going to improve upon your skill sets and their IT ability. So I think, and then you'll find out if they're interested in sticking around. If they are, they're going to find a way to try to get some resources and funding, and maybe that individual becomes a permanent part of your lab, but as an independent investigator. So you have to be flexible and willing, and to see how willing other people are. But to get them a start, to turn someone away who is really interested in doing research because, sorry, can't help you, I think that somehow you need to figure out how to share resources.
Yes, I do agree, and also add, can also add that when I did my PhD, I didn't have any money, and I did questionnaires in general practitioners' offices, and we sent the questionnaires together with from the lab to the offices. So it didn't take any. It took very little resources except from my working time, of course. So it is possible to do it, but especially in the beginning. So you need to start small, I think, and also in many countries there are not many grants in clinical chemistry, and that can be a very good reason to join clinical research, because if you do a joint mission with clinicians, there are more grants available. So most of my research is actually very clinically oriented, because and that then it's easier to get funding.
So you hit a nail on the head there. I'll just want to reiterate is that whether you're an MD or PhD clinical chemist or laboratorian, find yourself a young clinical emergency medicine, OBGYN, whatever your field is, and become partners. Yes, you might end up doing most of the work, but at the end of the day, it'll come full circle because you'll get the clinical expertise of that clinician. You'll publish together, and it'll actually enhance the work that you do publish with that clinical bent, even if it was in the discussion. But I think I encourage young investigators to find someone similar to them in a clinical field that they can maybe start their careers off, and it'll weigh. Sometimes the clinician will be doing more work, and then sometimes you will be. But as Paul so elegantly pointed out, I like what he said, do not say no unless it's a ridiculous request. We are not a grocery store in the laboratory, but we have huge resources to help other people who have no access to research. So
Don't say no, Fred, even if it is a ridiculous request. Just say, unfortunately, we can't do it like that, but we could do it like this.
agree
Okay.
100%.
There is one last question because we are running out of time now, but this is an important question. How do I choose my mentor? How to choose a mentor and how to get a mentor?
Two quick answers. Some institutions have a mentorship program, which you're assigned, which I think that's a great idea. And the other is you as an individual, when you're interviewing the process, explore that opportunity of mentorship. Or when you get to your job, search out the area and approach people. You need to be, as Paul said, there's different levels of fear. You got to be able to go there, and it's scary to ask, but you can only get rejected.
I think that's absolutely right. I think you choose the person you want to work with and then approach them. I mean, you may be. I was very lucky with Sydney because he was notionally my boss, and he thought it was his job to try and take this sort of clay and knead it and fire it into a highly beautiful vase going forward. But yes, I think that's absolutely right. You go and ask people, and you do it by degrees, because you ask them a little bit, and then when they find that actually you're quite receptive and sensible and take your ideas away. I mean, don't go and ask somebody for their advice and then ignore it. That's just daft. But then I think the other thing is, as Kristen said earlier, you try and make this a two-way street. So you say, how do I do such and such a project? If I do it, would you help me with the write-up? And so people go, oh yes, yeah, right, that's fine. And then they will be more receptive, but they'll also pass you on to other people.
And make sure, if you're a young investigator, you go to the senior mentor, you've researched the literature database, the PubMed. If you're bringing an idea to them, don't bring in an idea that's been published 3 years earlier. That will look bad. Make sure you really do your homework when you bring that idea, so he or she won't say to you, "We published that 6 years ago. You need to do a better job." That's not a good start.
That's right. The worst thing to do is to bring something that they published 3 years ago.
Yes, absolutely. Okay. We have to round up then. Thank you, everybody, for attending the webinar. And thank you, Professor Apple and Professor Collinson, for the beautiful lectures and this very good discussion. Of course, also thank you to Dr. Hamilton for coordinating this webinar, and to the IFCC office, Smeralda, for helping us with everything and offering this tool for e-learning. Please remember that if there is any unanswered questions, they will be replied by email, and the certificate of participation will be provided at the end of this webinar after a few questions. At the end of those questions, please click Show Me My Scores, and you get the certificate. And at last, the on-demand content of this webinar will be available in short, and you will be informed via email. There will also soon be other IFCC free webinars, and they will be announced by the IFCC communication, email, website, and IFCC social media. So thank you, everybody.
Happy holidays and Happy New Year.
Happy holidays.
Thank you, Chris.